Moving deeper into the NumPy package, in this video we will discuss the NumPy random function for generating pseudo-random numbers. We will see more functions with arrays that are called universal functions. And lastly, we will see how can we write NumPy data in files and read them back into our code. Pseudo-random number generation, or PNG as it can be found for short, is a useful task in many applications, for example for sampling elements from a collection randomly. It is pseudo because the generation of truly random numbers, that is numbers that are statistically unpredictable truly, is not really possible with the means that we have commonly available, that is with our home computers or our simple computers at work and the software that we commonly use. For truly random numbers to be generated, sophisticated machines and complicated systems need to be used, the reason for which is beyond the scope of our course. We have seen in previous lessons that Python has the built-in function random for generating random numbers, or pseudo-random, but I will sometimes just call them random for short. NumPy also has a random function which supplements the Python built-in random function. The NumPy random function is orders of magnitude faster than the Python built-in one when we use it for generating large samples. It also allows us to sample values from various probability distributions. So in this example here, we sample values from the normal distribution. To do so, we call from NumPy the random function, and from there the standard normal function, and we give as an argument the size of the array we want to get. That is effectively how many samples we want to draw and how we want to shape our array. Here we ask to draw 8 values, 2 times 4 is 8 samples, and put them in a two-dimensional array of 2 rows and 4 columns. And this is what we get as a result of this command. NumPy also offers us many universal functions, which are functions to perform element-wise operations in the arrays. These functions are also called ufunc for short sometimes. You can find unary and binary universal functions. Unary are the ones that take an array as an argument and perform some type of transformation, whereas binary universal functions take 2 arrays as an argument and perform an operation with the values of these arrays. Let's see how to perform some simple element-wise transformations using some unary universal functions. Let's assume that we have this very simple one-dimensional array of length 4. It has the value 0, 1, 2, 3, 4 inside. And let's assume that first we want to get the square root of each element in this array. For that, we can just simply call the universal function sqrt of NumPy with the array we want as an argument. And that will give us another array of the same shape as the initial array, where each element is the square root of the element of the initial array. Similarly, if we want to compute the exponent of each element in an array, we can simply call the universal function exp of NumPy and give the array we want as an argument. And then what we get is an array of the same shape as the array we gave as an argument. And each element of this new array is the exponent of each element of the array we gave as an argument. Moving on to some binary universal function examples now, assume that we have 2 arrays. Array X is a simple array, one-dimensional array that contains the value 0, 1, 2, 3. Then array Y, which contains again 4 elements, is again a one-dimensional array, but this time the elements are drawn from the normal distribution randomly, and here's how it looks like. If we wish to add these arrays together, we have seen that we can use the plus symbol to perform the element-wise addition, but we can also use the add function of NumPy, passing the 2 arrays as arguments. And what we get is a new array, same shape as the arrays that we added together, with the element-wise sums as its elements. Similar, we can use the maximum function for getting the maximum element-wise between 2 arrays, or the minimum, etc. Here is the result of what we get when we call the maximum universal function on these 2 arrays. Lastly, NumPy gives us the opportunity to store some NumPy structures in files. This, in my experience, is not very popular, as most people choose to use pandas for this, but it is worth knowing in case it becomes relevant in your work or research. So assume we have this simple, again, one-dimensional array of values 1, 2, 3, 4, and we want to save it in a file. So we can simply call the save function of NumPy and give as a first argument the file our array to be stored in, and then as a second argument the array we wish to store. When we want to load back the array into our code, we can simply call the function of NumPy load with the file we wish to load as an argument. And what we get is back our array structure. Notice here that when we write an array in a file in NumPy, the interpreter will always append the NumPy extension .npy at the end of the file. So if you forget to use an extension, don't worry about it because the interpreter will always add one. But if you give another text file extension, for example, txt, notice that the npy extension will again be added automatically, and that will create an extension npy on the already extension txt. So it's better to forget rather than give the wrong file extension. Notice that when you give the file you want to have your array stored in, instead of just giving the name of the file you want your array to be stored in, you can also give the absolute path to the file. Now, when we want to load back the contents of an npy file, the extension npy needs to be specified, else you will see that an error is raised. The takeaways from this video is that we can perform pseudorandom number generation with NumPy, and in fact, the NumPy random function is much faster than the built-in random function, and it allows us to sample values from various probability distributions. Also, we saw that NumPy has many unary and binary universal functions for simple element-wise transformations and operations between arrays. Lastly, we saw that we can use the NumPy functions save and load in order to write and read respectively NumPy data in files. See you in the next video.